and welcome to the demo on A-LSTM and XGBoost Enhanced Digital Twin for Smart Mobility and Environmental Monitoring in Westminster, London. This application is designed for the Council of Westminster, for the people working there to analyze various weather condition and traffic condition and how the air quality of a particular location will be based on these parameters. In today's demo, we'll have a short look at the project structure and the various components of the project and how they are deployed on a Docker container, and using Docker container how we can then host it on web using Cloudflare platform, and then followed by the demo. Now the repository that we have used for version controlling is GitHub repository, and this is the repository name MSC Family Project. And this repository then can be cloned to the local machine using git command or using the Visual Studio extensions. So I have used Visual Studio Code and Git extensions to clone the repository, and I can see all the folders and files here. The first folder that we see is artifacts folder, where we have the IPNB file or the notebook file, which was used for initial training of the model, for which is used for forecasting based on XGBoost model. And then we have the data that was used for initial model creation, training, and testing. The second folder that we'll talk about is the data pipeline folder here. So this has various Python scripts for consuming the data and writing it into the database. So we have two parts of each data that we are ingesting. Data primarily being the site data, the AQI data, the weather data, and the traffic data. We have used Kafka topics here for each of these components, and we have created a respective topic on Kafka for these, and then the producers will make a query to the respective data source, which are basically the APIs. For example, for AQI and weather, the API that are used are from Open Weather Maps, and for site data we have used Imperial College of London's API that they have hosted, which has location by council of City of London, so which is very good to create a site data in the tables. So all these producers write to the respective Kafka topics, and then the consumers listen on those topics, and once the data is on the particular queue on Kafka, it reads the data and then writes it into the Postgres database. One important aspect here is the main producer and the consumer, which are responsible for running all these producers and consumers respectively. And also the main producer here is responsible for triggering this this sequence of producer and consumer every hour of the day. The forecast producer here is only the producer which does the retraining of the XGBoost model. So the initial model that was created is loaded first in this producer, and then a new set of data is fetched from the Postgres for the last 365 days, and then it is fed to the model by doing a split of uh, 70 and 30%, and then after training the model, it evaluates the model. So testing is done, and then once the model is trained and tested, it is uploaded to the API. Now we'll talk about the next component here of the project, which is the REST API, which is the middleware. As we saw earlier, the data pipeline retrains and uploads the model to this REST API project under the forecast model. So these are all the different targets for the XGBoost, and also for the traffic, synthetic traffic data generation, we have used A-LSTM, which is also loaded here. So once the request for forecast comes to the REST API, it uses the model and then does the forecast and returns the value, returns the response back to the DT application, which is here. I'll talk about this a little later. So REST API has four major components. The API, this is the endpoint where the request comes. All the requests that comes are mapped with all these schema. So we have request and response models for the requests, for these endpoint requests, and then these models are then converted to the database models and sent to the services here. Now these services use the models listed here, which is sent after transforming from the schema to the models in the API endpoints. It is then sent to the service layer here, where it queries the database and then sends the response back to the REST API endpoint. Now, after the REST API, we'll have a quick look on the front end, which is written in ASP.NET Core MVC. So we have models and controllers here for the respective modules of the application, which is the dashboard or the home controller, the forecast controller, the analytics controller, and their respective views here. And then we have service client, which is created for connecting with the REST API. This also has this also helps import the JavaScript libraries which are used for digital twin for presenting the data, and then those libraries are loaded using the layout. So um, we have Session.js, which is which is used for creating this digital twin, and it represents the data in a geospatial format, and also it represents the buildings and other element of the digital twin in terms of in the form of tiles on those maps. We also have Chart.js, which is used for showing charts of the model performance, which we'll see during the demo. Now the Docker Composer file here is responsible for running all these various components on the Docker containers. For example, the DB, which is the Postgres database, the pgadmin, which is the UI for the DB, the Kafka and its UI, and the pipeline, consumer and producer. The radius, which is used for maintaining the consistency between various predictors and target variables. The API, which is responsible for, which is the REST API, which we were talking about, and the front end that we saw, which is MVC app here. Now, once the container is spun, we see all the services running on Docker like this. We need to run most of the services, but running Kafka, which is the UI for Kafka, and Redis Commander, which is the UI for Redis, and pgadmin, which is the UI for Postgres. These are optional, these three things. The remaining all are running here. So once these containers are running, we can access the application front end using this particular localhost link. But if we want to host it on web, then we go for a service called Cloudflare, which registers a domain and redirects all the traffic that comes to that domain to the local host service that is running here. So it looks somewhat like this once it is running, and after starting and once it is executing, so you can access the front end using the domain that you have registered with, which in my case is this. So once we type in the URL, we see the dashboard here, which is the default page, and we see the dashboard for the LSTM that has been used for synthetic data creation for traffic. We see quite consistent performance over time for this model, which is close to 80%. And then the second model that we have used, which is XGBoost for the air quality index and the pollutant prediction. So for air quality, we see metrics in terms of R square, RMSE, and NAE for the XGBoost regressor. And here also we see R square is quite consistent and close to 1, which is a good metric for a model. And likewise, we can see for various models here. For example, for CO, again we see it is close to 1. You can hover on the points and see the exact value. So these charts are also interactive. You can see various pin and its values here. The next tab here on the top is for analytics, where we can view the past historical data on digital twin. So you see your digital twin is loaded with the past data here. You can see the buildings, trees, and everything. Now, if you want to see how the traffic was and the weather was, and also the air quality was for for this location, you can click a day in the past or a previous hour, and you can see it loads the data on the digital twin. So you see the ellipses that show the air quality of that particular area. In the center, you see some dots which reflects to the traffic flow. So if the traffic flow is very high, which is very less traffic, then you see a green dot, and if you have very high flow, then you see a red dot. Sorry, a very low flow, then you see a red dot. Now for air quality, if also the color indicates how the air quality was for that area. For example, for now it is fair, and also the wind direction you can see with respect to the north here, which is the guide, and the size of the arrow indicates the speed of the wind. And if you want to see exact values of these components, you can click on a particular pin, and it shows the weather conditions for that area, the air quality and the pollutant, and the traffic conditions. Now, to validate if digital twin shows the correct data, we can move back in time on May 2nd at 2 p.m. Sorry, 2 a.m. in the morning. And you see, during that time, the air quality was very bad. The red shows very poor, which is 5. And also, you see a lot of traffic in these areas. Here we have very low flow of traffic, which is a high traffic. And even the orange here indicates the moderate low flow, which is still a high traffic density. Now let's see how we can forecast for a future date. So once we click on forecast, it loads the forecast of the current hour. So for now, it is showing at 12 on 14/8/2025. It shows decent air quality, which is fair, and even the traffic conditions are not bad. So there's high flow of traffic, which means very less traffic, and even the weather conditions are favorable. See a lot of high speed wind in the southwest directions. Now let's also look at a future date. So if you want to do that, first set the parameters. So we have set all the parameters to high and save it, and then select a future date and time. For example, we can do a forecast for next 4 days max at the moment, because the weather data is available only for next 4 days. So let's see on Sunday midnight how it will be. So we see, even though the traffic conditions are very high density, still the air quality index is not bad, and that can be because of the weather conditions, because the wind is high, so the all the pollution and will be carried by the air away from the city. And then we can look for any uh, which is known for a lot of traffic and pollution, let's say 5 o'clock in the evening. Once we select this, we see a spinner running. Now it is being analyzed. Now see, at this time with high traffic, the air quality has degraded, has become moderate or 3. So using this digital twin, we can analyze data from the past using analytics, or we can also do forecasting based on certain parameters that we set here. And this will help the council decide on planning the events and how to divert the traffics and avoid bad air quality in that particular location. So that was about the demo. I hope you liked it. Thank you.